This paper is a joint effort between Bernardo, Ali, and myself to show that one's race varies over the life cycle. In tandem with a growing literature in demography and in the sociology of race, we argue and show that race and skin color in Brazil is not a permanent and fixed attribute, but a provisory state that changes as one ages. We're not the first to demonstrate the fluidity of racial classifications. Dahis and colleagues show that about 20% of black men passed as white during their lifetime from 1880 to 1940 in the Mississippi Delta. Similarly, Saperstein and Gullikson show that about 22% re-identified from the black to the mulatto category in the beginning of the 20th century. More recently, Saperstein and Penner, in a paper published in 2012, showed that about 10% of individuals changed their racial responses between 1979 and 2002. And finally, in a seminal work, Caroline Liebler and others show that 6%, which is about 10 million Americans, changed their racial identification from 2000 to 2010. Several efforts have also been done in Brazil to investigate the process of racial reclassification. José Alberto Carvalho, Charles Wood, and Flavia Andrade were one of the first to suggest a demographic strategy to measure racial reclassification by comparing projected and observed populations by race. The logic is straightforward. Whenever there's a difference between projected and observed race-specific populations, there is racial reclassification. Later on, Vitor Miranda used this strategy to show that one in every three blacks in Brazil reclassifies their race. This accounts for a net gain of about 3 million newly reclassified blacks in the 2010 Brazilian census. More recently, other authors such as Cornwell, Sienkiewicz, Leonardo Silveira, and also Ed Telles and I have been using linked and longitudinal data to infer the share of individuals who have reclassified their race in Brazil over time and across space. We find that most flows are symmetrical and happen between the white and brown categories. So in our paper, we have adopted an original and unique demographic approach to investigate racial reclassification over the life cycle. In particular, we are interested in answering the following questions. How long could one expect to live in a given race? At what ages are transitions between races more likely to occur? And how many years can someone born as white, brown, or black expect to live in another race? To answer these questions, we use nationally representative data collected by the Brazilian census and apply the tools of multistate methods. In particular, multi-state life tables, they require rates or probabilities of transition between predefined states, which in our case are the three most prevalent races in Brazil: white, brown, and black, and also death. So these are our states. So to be clear, we combine these two inputs, mobility and mortality, to estimate multi-state life tables using a stated program developed by myself and published in the Stated Journal last year. This program is awesome because it makes the task of calculating increment-decrement life tables a breeze. Multi-state demography was hard to implement. Now, with MSLT, it isn't. So we calculate transition probabilities between races using linked data from 2017 to 2019 continuous PNAD, a nationally representative household survey. So the logic here is quite simple. We cross-tabulated the race reported in the first interview with that reported by the same person 9 months later. This strategy gives us probabilities of racial reclassification by age. We calculate race-specific life tables in order to have the probability of transitioning to the absorbing state, also known as death. So we use an iterative variation of the death-based method to get these life tables by race, and as a consequence, race-specific life expectancies. A data program, not yet publicly available, was specially developed to implement this iterative procedure. And this method was first developed by Giovanna Merli and published in Demography in 1998. So points 2 and 3, therefore, are the required inputs into the program. Racial mobility patterns indicate that blacks have the highest probability of transitioning to another race, to the brown category. This table also shows that the share of whites who reclassify as brown is larger than the share of browns who reclassify as white. Moreover, whites are more likely to reclassify to the brown category at earlier ages, before their 35th birthday. Finally, notice that most inflows happen from the white and black states to the brown racial category. These results are thus compatible with previous literature, which shows that more than 85% of all racial reclassifications are to or from the brown category, corroborating the idea that pardos represent the most fluid group between pre-established racial boundaries. In terms of mortality, we estimated that those who were born white will live almost 73 years. In a cohort of browns or pardos, life expectancy at birth was equal to 68 years. And blacks, similar to browns, could expect to live 67 years. And here's the level and age pattern of mortality by race, taken from estimated race-specific life tables. It shows that typical hump in mortality between ages 15 and 25 due to external causes, and it also shows that blacks and browns have a similar mortality pattern, higher than that of whites. So after combining the probabilities of race-specific mobility and mortality, we get a table like this, which is the raw input required to estimate multi-state life tables by race. The probabilities of dying for whites and browns become higher than their probability of reclassification after ages 65 or 60. That is, before these age ranges, people are more likely to reclassify their race than to die in a given racial state. It's also worth pointing that the highest transition probabilities are from blacks to browns, varying from 20 to 30%, followed by whites to browns and browns to whites, which are in the range of 7 to 14%, depending on the age group. Also notice three other things. First, within each race, these probabilities sum to 1. Second, the probabilities of remaining in each race are not shown and are not required for the estimation. And third, in the last age group, individuals can only move to the dead state. Thus, in that age group, the probabilities of racial transition are equal to 0, and the probabilities of dying are equal to 1. So using this data, we get unconditional life expectancies and some relevant summary measures. So first, regardless of their state of birth, on average, individuals could expect to spend 17 years of their lives as white, 24 years as brown, and 3 years as black. So from a cohort perspective, most of their life would thus be spent in the brown state. Unconditional life expectancies, therefore, combine the experience of cohorts born and dying in all states. So the program that I developed to estimate multi-state life tables in Stata, in addition to unconditional state-specific life tables, it also sheds some useful summary measures, such as the proportion of life spent in a given state, the probability of dying in a given state, the average duration of state I, and the mean age of persons in a given state. So, for example, individuals in these cohorts could expect to spend 21% of their life as white, 30% as brown, and 4% as black. Moreover, we estimate that individuals are more likely to die while in the brown state, with a probability of dying equal to 57%. The average duration of state white and brown is about 8 years. And finally, we calculate that the mean age of persons in the black state is about 30 years, and in the white state is equal to 27 years. Finally, another set of results given by multi-state demography refer to conditional or status-based life expectancies. Conditional life expectancies refer to the lived experience of a single cohort born at a given age and in just one state. It does not reflect the experience of any particular individual, but proxies the levels of racial fluidity across the population. So they differ from unconditional estimates by considering the lived experience of a single cohort born in just one conditional state. So to illustrate what they mean, we calculate the expected number of years to be lived by individuals who were born white, brown, or black. Our estimates showed that someone who was born white, for example, could expect to live 35 years in that same state, but 43 years as brown and 6.4 years in the black state. Alternatively, someone who was born black could expect to live 27.6 years as white and 43 years as brown. So after applying the methods and techniques of multi-state life tables to racial states, we have concluded that first, race can be understood as a changing propensity rather than as a fixed state. Second, our conditional estimates of life expectancy show that regardless of the state where one was born, at least 42 years will be spent in the brown state. Those who were born black could expect to spend almost 28 years as white, and those who were born white could expect to spend 6 years in the black state. And third, multi-state life tables should also be used to understand other phenomena marking different states of the life course. We could think, for instance, that by monitoring fluidity regimes would shed light on our understanding of times and propensities spent in different states, which could also be extended to religious or political affiliations, employment, health and marital status, geographic mobility patterns, and also understood as economic classes, as argued by Robert Schoen in a 2020 demography publication. We thus claim that pursuing an agenda for monitoring such fluidity regimes through increment-decrement life tables is a much needed research endeavor. And that's all, folks. For further information about this presentation and the methods discussed here, check these two key references and please get in touch through the email shown in the screen. Thanks.